Okay, great. So my video is not coming for some reason. Anyway, we'll get started. Okay. So guys, today I'm here with Bikram. Okay. I will check my video one more time. Meanwhile, Bikram can start. Okay. So I'm very fortunate to have Bikram here. Okay. And I thank you all for joining on this time actually. So Bikram is one of the very well-known name in the industry. Very Bikram is in data science industry since many years now. Okay, he has written couple of books as well. If I want to give introduction, it will be a lot. So I'll let Bikram speak. Bikram, would you like to introduce yourself to the people over here?
Sure. Thank you, Aman, for this opportunity. I'm very happy to be with you this evening and the rest of the students who are a part of this program. And you're very kind. You spoke very generously. But yeah, I mean, I have been in the industry for quite some time now, about 12 years in the industry doing data science. Uh, yeah, I mean, I have been a part of services organizations, product organizations, worked in delivering services assignments, built data science analytics products ground up. So that's the experience that I have, and more than happy to help you if you have any queries that I can help with. Yeah, so I will let you ask questions.
Sure, sure. So, Vikram, I would just start with, if you can talk a little bit about how did you start as a data scientist and long back, what were the learning facilities that you had? What were
Mhm.
the things on the web or what were the things you referred?
Mhm.
And how did you land up in data science? All those kind of things for the young data science folks, if you want to talk about.
Sure. And that's actually an interesting question because I am not a PhD statistics person. I have done my BTech in computer science. Right after I passed out, after a couple of years when I was working with Microsoft, my interest towards data increased significantly. I could see how data science analytics was shaping up. Back in the day when the social media boom was happening, right? The dawn of Web 2.0 and Web 3.0. It's like all of a sudden, the data coming in from every nook and corner, and everyone started talking about data. That was the time when the big data ecosystem came up, right? The Hadoop ecosystem to start with. So it is like there was a lot of boom back then, and I was one of the early movers, I would say, who was very, very curious to understand, how gaining insights from data could really give you that competitive advantage you as a business, right? So I was pretty fascinated by that, and I learned on my own, data science. Back then, there were very few internet articles, so to speak. Andrew Ng, his videos and his articles were very, very helpful. CS229 from Stanford. These are some of the master references that I always studied. Together with that, there is a very good book that I happened to come across. I just wish that somebody had told me before I started this journey. So it's like after I spent about a couple of years, then I got to know that hey, there is this book, Introduction to Statistical Learning, ISLR, very, very famous book, that really shaped me up as a data scientist. I must say that a lot of credit goes to the book
Mm-hmm.
that I read back then. And yeah, I mean, it's like uh, apart from all these explorations, going through web articles and good books in data science, good articles, good video tutorials. Apart from that, what really helps, is getting your hands dirty. You could keep reading all your life, but when you actually start doing things, that's when the real change happens. That's when you start to understand things in a better way. Putting so much of theory and textbook content in your brain, only that part doesn't really help. So that has to be mixed with a lot of practical. So I It's a lot of pain to endure, though. It's like you don't really understand many things in the beginning, and you still have to have patience. You still have to have courage that you can do it, right? So I can do it. That attitude is very, very important because it's an ocean. It never ends. And that's the beauty of being a part of the data science world. And that's why possibly I became a data scientist, and possibly Aman, you became a data scientist, and possibly the rest of the folks who are a part of this session, they are willing to get into data science because of this beauty, right? So there is endless learning. As and when you grow, you continue to learn. So that's the benefit that you have. But yeah, I mean, coming back to your base question, so it's like, apart from the books and tutorials, the internet articles that are there, a lot of lots and lots of hands-on, lots and lots of practical. When you do it yourself, that's when you actually learn it. So that's how my journey started.
Yeah, very true, Bikram. So, once you get into that, once you get your hands dirty, and then, you get to know how the data is working, what the data is telling, what should
Yeah,
be the next step, what is making sense, what is not making sense, right?
correct.
These things. Another thing I want to know from you, you have been in industry since some time now. So, what is the difference between, when you started and as we see industry right now, and how do you see the industry shaping up? What kind of skill sets, what kind of people, what kind of, you know work will be there in the market? How do you see all these as a whole?
Yeah, this question actually has many facets. To start with, I would talk about the opportunity. When I started, the opportunity was tremendous, and the opportunity has only grown with time. So this is something that has been consistent the way I see it. Uh, there were lots of opportunities back then, and there are lots and lots of opportunities even today. Even though there are so many data scientists graduating, there are so many people pursuing data science as a career. What has actually changed is, how you benchmark yourself as a data scientist against the industry standards. So back in the day when it's like very simple rudimentary questions that are asked during the interview. For example, how do you handle a class imbalance problem? What is a sigmoid function? What is multicollinearity? You answer these basic questions and you are through. But today the situation has changed. If I am on the other side of the table, I would. So these are the questions that I also ask, by the way, but we rarely get good answers. I would ask, so tell me why multicollinearity is a problem after all. If there is multicollinearity, then what's the problem? Now, this is where I would like to see the depth that you have as a student. Have you really understood the various ways you can do regression? Have you really understood, you know, um, when you import from scikit-learn linear model, when you import linear regression, uh, is that a algorithm? Is that library is built on ordinary least square OLS, right? That uses closed form solution to solve a regression problem, or is that something that is based on, let's say, stochastic gradient descent, right? So these two have two different. So there are different approaches to regression, and when somebody asks you a question like this, you should answer them in two, three different ways, right? So it is like, you understand that there are different kinds of regressions. And the reason I'm telling you this today is because there are not many people out there in the industry, especially the freshers, who know that there are different regression techniques, right? So OLS is something that we read. OLS is something that we use when we import from linear model, import linear regression. But in the same scikit-learn, we have SGD regressor also. So have we used that? And the presence of multicollinearity, for example, the problem that they cause are different, of course. With SGD, that's a different problem. With OLS, it's a different problem. So I would expect, that deep-rooted answers to see, if you really know it. uh, I would be very much interested in knowing what you know, and what you don't know, and what you know you should really know. That's the expectation that I would have. For example, you say that you as an interview candidate, as an interviewee, you say that regression is your favorite, decision tree is your favorite, random forest is your favorite. I ask you, what is random in random forest, and you don't have an answer. I ask you a very practical question. How do you find the depth of a tree, after you build a tree? You don't have an answer. But but how did you then execute a project, when you actually used grid search to optimize the hyperparameters, apart from the n estimators, for example, in the forest, how many trees, apart from that, you also talk about the depth of the tree or the height of the tree. And the sklearn, the scikit-learn implementations are, the decision tree methods are post pruning method, right? So it is a variant of the 4.5 and card. So it's a post pruning method. This means that ideally you would have grown a tree, you have understood the depth of the tree, right? And you can ask the trained model, right? What is the depth of the tree? It will tell you, right? There is a switch that you can ask. So and now you know that the actual height of the tree is, let's say, 200, right? Then you sort of put your numbers, let's say 10, 15, 20, or 30, 40, 50. So it is like, what numbers do you feed into the grid search, is something that should come from this rational. So it is not like, you don't even know the actual height of the tree, but you are pruning at 2, 3, 4, 5, 6, 7, 10 to 20, 30 to 40, 50 to 60. Is that a very good way of doing? No, right? Because everything that you do as a data scientist, there has to be a rationale behind it. When you say that I divide my data set for training set and test set 80-20, why 80, why 20? There has to be a rationale behind it, right?
Yes. Yeah.
So yeah, so that's the expectation. That's how the expectations have changed of late. So more hands-on data scientists, with very good fundamental. It's not necessary that you know everything, but whatever you know, your foundation has to be strong. That's actually the expectation in the industry right now.
Yeah. Thanks for the answer, Bikram. There are some questions flowing for you. So
Sure.
Raghav is saying it is important to understand the basic maths behind each algorithm we study.
Yeah, is there a question?
Yeah, he's just agreeing with what you are saying. So
Okay, okay, yes, but there is a pointer that I would additionally put in there, which is, mathematics is definitely important, but don't let mathematics be the starting point, because if you make that happen, your learning becomes slow. So I would prefer that you take an outside-in approach. Every new data scientist out there in the market, when this is my personal suggestion, right? So I prefer that you take an outside-in approach. You may not understand the nitty-gritties of it, you may not understand the mathematics of it, but take an outside-in approach and understand it at a 30,000 feet, then understand it from a 10,000 feet, then understand it from a 5,000 feet, and understand it from ground zero, right? So so ground zero is your mathematics, right? So that gives you a very good perspective. Otherwise, you lose interest. The moment you get into mathematics, it's so much of mathematics that you lose interest. So that's very common, and it doesn't give you a very comfortable feeling to mathematics being the starting point.
yeah, sometimes that might take you in a little boring zone, and you might be.
That's right. Yes. Yes. You might be a victim of boredom.
Yeah.
Yeah.
So Ramanan is asking, sir, I'm a fresher and I was learning machine learning and I'm not strong enough in deep learning. Is
Mhm.
that recruiter looking only for deep learning now?
Well, you see, deep learning is also machine learning, right? It's just uh, neural networks, right? So yeah, I mean, off late, what has happened is, because of the NLP requirement and because of the computer vision requirement, they have gained more popularity. But it is not that deep learning is everything. There are still a lot of enterprise problems that are not solved using deep learning. They're actually solved using conventional machine learning methods. However, knowing deep learning is important because you never know, as a company, as an organization, you might need deep learning expertise going forward. So these days, I see that many organizations, even they don't need it immediately, deep learning is a requirement. They expect that the students also know deep learning, but learning deep, if your fundamentals are very good, you actually understand uh, uh, the conventional machine learnings well, then you can also pick up deep learning. Personally, when I interview, if somebody doesn't know deep learning, I'm fine with it, honestly. But that may not be true all the time, right? So it depends on the company that you're getting into. And if it is a hardcore NLP based company building some product in NLP, building something on computer vision, then you will have a steep learning curve, and they may not want to invest the time and energy on you to groom you and to bring you up to speed, and then you will be productive. They would possibly prefer somebody who is a plug and play. You get hired and you start working. So that is why. So it's good to learn, and there is no big deal learning deep learning. Just set aside a couple of weeks for yourself. Be honest with yourself, and you can pick it up. It's good to know it, I would say. Yeah, if that
Yeah,
answers your question.
thanks, Bikram. So, one more thing, Dilip is asking. There
Mhm.
are a few interesting questions actually. Dilip is asking, I have few doubts. May I know why company is asking for Linux, Unix, Git, AWS, Dockers, and Kubernetes?
That's a good question. Well, you know, you actually need to understand what do you do as a data scientist in a company. Okay, so uh, the very definition of data scientist is that you know more programming than a statistician, you know more software engineering than a statistician, and you know more statistics and machine learning than a computer science engineer. Okay, so that is what is a data scientist, because you execute things. Otherwise, what will happen is there will always be a disconnect. You say trained model, and the software developers don't understand what a trained model is. The data engineers don't understand what a trained model is, and it is very difficult to explain to them that, hey, it is a trained object. Your machine learning algorithm churned or processed the data, and it built a trained model that's there in the RAM, right? You possibly have to serialize it and store it on your hard disk, and then ship it to a different server. Read it back again to the memory, and then it becomes a trained model again. So it's very difficult to explain such things, and to be able to productize, to be able to deploy a machine learning model in production, it is extremely important that a little bit of scripting. These are very easy to pick up. By the way, there is no big deal learning these things. Working in a Linux environment, so understand that you are definitely going to work on Python or R, right? Even if it is a Linux environment, it is easy actually to build microservices, to write a small script, and to automate a few things, to build a pipeline in production. Knowing cloud is very important, because many companies out there, they wouldn't want to. So you see, all the deep learning algorithm, the machine learning algorithm, they're very compute intensive, and a lot of companies out there, they prefer this to be on the cloud. That is why, if you have some bit of experience on the cloud, then again, the learning curve for you won't be that steep. But if you have absolutely no idea, then it is difficult, because you will have a steep learning curve. Again, that the time that you would take, I as an organization may not have that appetite to give you the time and space so that you can groom yourself. So that is why it is a good idea. And these are not tough things, by the way, right? So working in a Linux environment, or knowing a little bit of scripting, knowing a little bit of SQL, knowing some bit of cloud, this is no big deal. Of course, there is so much more to learn, but you can learn over a period of time. But there has to be some basics built in, so that it really helps you, be successful in your data science job. That is very important.
Yeah. That's a very, very detailed explanation. I hope that solves that, gives the answer to Dilip. Dilip, you can just text us. And Ayush is asking another interesting question. Ayush says, if people are asking, deep learning is the key for problem solving, then why can't we skip ML and go to DL directly?
Well, uh, 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 that is well. I was just trying to think of an example, but I failed. You know, you see, deep learning is also machine learning. Don't think that deep learning is something else. What is deep learning, right? Deep neural network. That's it, right? And neural networks, training a neural network requires you to learn machine learning. That is machine learning. It's one of the machine learning algorithms. You see, the same way, it's how you learned logistic regression. It works differently. It works in a certain way. When you learned decision tree and tree based methods, it's a different algorithm, right? There is no similarity at all of a tree based method and logistic or linear regression. You see, there is no resemblance at all. Now that's a different algorithm. Similarly, deep neural network, forward propagation, back propagation, right? You learn it, but you see that the other components to it are still the same. Do you not use a sigmoid function? Yes, you use. Yes, in deep neural network, don't you? Let's say that if it is a classification problem, you definitely use a sigmoid function or a softmax function. You have to use it, right? You still have the notion of precision and recall, don't you? You still have it, right? So it is just the algorithm that has changed. But if you look at the entirety of the machine learning problem that you're trying to address, has anything changed? Even cross validation, even though you have so many epochs and all, even the cross validation is still important in deep learning, right? Cross validation is important because that shows we do cross validation for model stability, and almost every machine learning model in production, ideally you should be doing cross validation, right? So cross validation is a technique that still applies to deep learning. So what I'm essentially trying to convey here is, you know uh, just the algorithm has changed, but overall machine learning approach, the way you would build a machine learning pipeline in an enterprise setting, in a production environment, is still the same. Yes, instead of CPU you might be using GPU, but talk about your data acquisition, talk about your data pre-processing, talk about your model training. What has changed? Nothing. How you deploy a model in production, how you monitor it over a period of time, whether it is a conventional machine learning problem or it is a deep learning problem, what has changed? Nothing. Hope that answers.
Thanks, Bikram, for that answer. Santosh is saying, I want to understand about incremental learning.
Hmm.
I was just going through CREME, but I didn't got a proper example.
Okay.
Any suggestion on how we can implement incremental mod training?
Incremental model training, you mean, is it?
Yeah, model training is saying.
Okay. Well, I honestly don't understand your question fully, but let me formulate the question in my way and you tell me whether I've understood it right or not. So, are you talking in the lines of uh, online learning? So, as and when the data arrives, because you may not have all the data at all the time. So, as and when the data arrives, you want to update your model, right? Is that what you're asking? You could say yes.
Is that what
Run.
you are asking, Santosh? We can come back to Santosh's question again. Rohit is saying how to handle imbalanced image data set.
Well, why don't you answer this, Rohit? It's a good question.
Yeah, Santosh is saying yes, retraining of model based on new incoming data.
Okay, okay. So let's finish that up, right? So because now that is validated, you see, yeah, uh, in the olden days, in the by using the conventional machine learning method, and even today, right, using the conventional machine learning methods, when we build a model, we deploy that in production. It is never a one-time job, right? So after you deploy that in production, you still have to maintain it. And this model that you have built, considering the data that was available to you, that you were accessible to, using that you build this model. Now the nature of the data could change, and it actually changes in most of the circumstances, right, in most of the scenarios. So as and when you see new data, you definitely have to retrain your model. Now either you you know uh, take it as a batch and just you know train your model with all the available data that you have. If it is a if it is a small data that you're talking about, okay, so you can still use all the data that you are accumulating over a period of time and train your model. It may not be a best approach all the time, right? You would know why, because if your data can be overwhelming in size, it may not work. It so it is like very data to back in the history may not be as useful for you because it depends on the type of problem that you're solving, right? So in that case, also too much of historical data may not really help you build a better model. Possible, right? So in that case, what you can do is you can do something like a sliding window, right? So it is like as and when the data arrives at your premise, together with the historical data that you have. So it is like, let us say that initially you had 1,000 records, now 100 you have, and all in all you are using 1,000 records to train your model. Now you shift this 1,000 100 on the right, so that the initial 100 that you have is very old. Now that's gone. That's not a part of the training. So 900 from the past and 100 from the present. You can do like that. So there are examples where you train your model like that. So this is the second method, and the third one is more so. For example, you could talk about a deep learning environment where you have trained your model, right? You have the weights captured already, and you do transfer learning, right? So that is another way, but that you can do only when you're talking about a deep learning scenario, right? So that also applies. And then for regression problems, stochastic gradient descent is something that is very popular for online learning. As in when new data arrives, you can train your model on the fly, right? So it gets adjusted on the fly. So that's something that you can do, but it could also give you surprises once in a while.
Yeah.
But yeah, yeah. So that's the answer to your question. Yeah. What was the next question, Aman?
Someone is asking you and Sama, I'm a .NET developer, want to change my domain. This is a generic question, hence I'm taking it up.
Mhm.
.NET developer want to change to data scientist. Suggest me something that will help me to change my domain. I know machine learning and deep learning.
Well, I would say that if you know .NET, right, that shows that you come from a programming background. So don't think like you're changing your domain or something, because as a data scientist also, if you come from a good programming background, that really helps more than you can imagine. Okay, and day in day out when we interview a lot of candidates, people with very little programming experience who have good knowledge of data science are not very useful. In an enterprise scenario, you say that you know these algorithms really well, but you can't code at all. I've seen people like that, and in my experience, what I have seen is they are very least useful in a team. Okay, this is a very blunt and honest feedback that I have, and that is why you coming from a .NET background, so whether it is .NET, whether it is Java, if you are experienced enough, at least a year or two, programming any programming language you can pick up, right? So there is no big deal for you, and leverage that to your advantage. Use that to your advantage and build on it. And machine learning, if you know well, data science fundamentals, if you know well, do a lot of project, and then you are ready, right? So So I think you can be there soon.
Yeah. So just couple of more questions we will take.
Mhm.
Okay. So just some random I'm taking, guys. So don't mind. Okay. So how to explain data science project in resume?
Okay. Well, you should give a brief description about your project. What was that project all about? Even if that's a project that you have copied from Kaggle or that you have done from Kaggle, always ensure that you as a data scientist, what you're trying to convey is that you are a problem solver. Okay, you are a data problem solver. It's not just that logistic regression and decision tree and forest and XGBoost and light GBM and the deep learning, but you're a problem solver, and that is reflected by how you summarize your projects. Okay, so give a business context to it, a couple of lines, and say briefly in 2 3 lines how technically you solved it, right? Say something that was special about it. Otherwise, what happens is when we skim through the resumes, it gets so boring. It's like there is nothing in the resume at all. But write something that will attract an interviewer's attention, or the whoever is assessing your profile. It attracts their attention. Oh, this guy did something special, right? So a jargon you can use, something that's not very common. For example, you imputed the missing values using XGBoost imputer, XGB imputer. Yeah, that's not as common. You see, at least it's not as common as you doing mean median mode substitution, right? So write few things that are not very common, and try to do those things, so that you have a first hand experience. Not that you're throwing bolos in the dark, right? So you have actually done it, and if the interviewer asks, and it is another way, by the way, it's a trick for the interviewer to get trapped in your net. So it is like you want your interviewer to ask you the specific questions because they're very well prepared for it. Yeah. So to summarize, write a couple of lines on the business problem. You see, why did you do that project, or what was the business outcome of that project, the assignment that you took, even if it is from Kaggle. Make sure you understand that really well, because as a data scientist, that is something that is definitely expected of you, right? So, and then few lines on the project. How did you solve the project? Don't make it too bulky. Don't make that like so it is like whether you did it in R or Python. I am least bothered. Any good data scientist would be least bothered. So it is like for us, R or Python are like tools. As long as you can solve a problem, I'm good. Whether you are an R person or you are a Python person, I don't mind. Trust me. But yeah, I mean, so don't emphasize more on that. You can choose to mention those, but don't emphasize more on that. Write what makes more sense in the description. And additionally, always remember when you are going through an interview, when the interviewer asks you, when the interviewer asks you a direct question, uh, you know, um, uh, try to answer that direct question in a direct answer fashion. So it's like, it's one word, one liner answers. But the interviewer can ask you to explain your project. That is your opportunity. That is where you should just open up, tell things to the interview, and you should be able to explain your project for at least 30 minutes. If you are not able to explain your project for at least 30 minutes, trust me, you getting through, the chances are very, very less. Okay, if you can explain your project for 1 hour, then it's wonderful, right? So that is the time that you can consume from the interviewer, because they don't have a lot of time within that 1 hour that they have budgeted to take your interview. After going through your projects, reading those descriptions, when they ask you, that is your opportunity, because that's where you can sell. That's where you can talk about the interesting things that you did. You can talk about what worked, what didn't work. So this is another area, right, where You need not just say that, I loaded the data, read.csv, build this model, accuracy was this much, and then that's it, right? 2 minutes, your project is over. I'm also interested in knowing, what were the challenges, where did you fail, what worked, what didn't work, so that it's not necessary that, just tell me the finished product. This is how it looked like. You should also tell me, hey, I imputed XGBoost imputer, I imputed missing values using XGBoost imputer, but it imputed with some negative values, -1. It's a possibility, right? Those of you who have done it, you would know it. So now I'm interested in knowing, oh my God, what's that scenario now? You see? Somebody says that after using XGBoost, at the end, I I applied either some sort of a sigmoid function. Usually you would know that if you have practically worked, XGBoost in classification methods, the probability value that it spits out are not scaled well, right? So you tend to use some isotonic regression or a spline-based method, or Platts regression, right? So there are so many techniques out there. So what it essentially does is it scales your probability values in a sigmoid sort of ways, right? So it does. None of these are practical aspects, and these are not very common. You mentioned those things. I'm more interested, more curious to know what you did, how you did, right? So attract the interviewer's attention to those areas that are not very common. That will help you.
Yeah,
Any other question?
yeah. Thank you so much for that detailed answer again, Bikram. People are saying a lot of thank you to you.
Thank you,
One
everyone.
la one last question we will take. One last question.
Sure.
Uh, can you any recommended project to work on for, let's say, a newcomer in data science? So I'm taking from Shania.
Uh-huh.
It may be a generic question, hence I'm taking any projects which will make more sense for newcomers.
Well, there is nothing like that, Shania. All that you need to do is do a lot of projects and do a lot of. So it is like, let us say that you've started with regression, solve some 4 or 5 regression problems. When you're doing decision tree, solve some classification problems using decision tree. Don't use anything else, just decision tree, solve some 4 or 5 problems. Those same problems you can also solve using, for example, KNN algorithm, using random forest, or using SVM, right? So that way you will learn a lot and do a lot of varieties of problems, and do some problems by looking at the answers that others have done. Start like that. There is no harm looking at others answers, because you are a newcomer. You want to develop some perspectives, how to think data science, how to approach a problem. So that will give you a lot of a basis to think. It will give you a lot of perspectives to think. And post that, you start doing projects on your own also, right? So that way you don't lose your originality. And you can possibly you can come up with a better answer, a better approach than other data scientists, because we all have unique brains, right? So more and more projects, don't be very choosy. So it is like, pick any project, go through the so it is like, as and when you learn concepts, browse a lot of projects day in day out. Try to do some 30-40 projects. It's a lot. It's not that easy, but if you target some 30-40 projects, then it will definitely build you up, that I can guarantee you. And when you look at the answers, you would know that, whether this project, the kind of work that these guys have done, it's like only some 30-40% you don't know, but 60% you know. Then go do it. I mean, you are able to understand by looking at the code, then just go and do it, because that's 30-40% of the components you can pick up on the fly, right? So that way, do a lot of projects. That's the key.
Yeah. Uh, Bikram, I would also not let this opportunity go without people knowing about your books. I really like your books, and it's so nicely written that it is equally useful for someone new to data science and someone who has spent couple of years or more than that. So could you please talk about your books which is available on Amazon so that
Well,
people can.
the first thing that I would say is possibly right now don't read them. There are other better books. You know, the book back in the day when I wrote them, they were very useful because I've worked really, really hard. Even if it is not, I would be biased to say that.
Mm-hmm.
But of late, what has happened is, there are the books are primarily they were targeted for engineers who are in the big data space and who want to build a career in data science. But then I tried and give a very good perspective on data science, the fundamentals, how to pick up some stats component, some data science components, and then connect all those things back to big data Spark environment primarily, right? So that is how I had written that book, and of late there have been a lot of changes to Apache Spark, right? So from the Spark perspective, few components are obsolete, but a majority part of the book are still very useful, right? So it's a choice that you can make, but I strongly recommend you to read Introduction to Statistical Learning 5 times at least.
Mm-hmm.
Yeah.
I'll just drop a link to that book in description of this video as well.
Please do, because that's a very very nice book. It is just to draw a parallel. You must have studied concepts of physics by H.C. Verma, right, in your schools and colleges. That book, I see the first one. There are two volumes to it, right? The first book, I guess he took about 10-12 years to write it. It's such a very simple and great book that helps you learn physics so well. That is the outcome of his 12 years of effort. You see, so similarly, Introduction to Statistical Learning is a book that was written with so many things keeping in mind, and that gives you a very good perspective of data science. And post that, you will be ready to explore other articles, because what happens is, there are a lot of articles that are not as great also. They few of the articles could be harmful also, right? But once you read a very good book from a very good author, uh, and you have a very good fundamental built for yourself, after that you're self driven. Any article, just by reading it, you will know the depth of it, the strength of it, the quality of it, and then you can judge for yourself. And you can be very selective in reading articles, and more the articles that you read, more better sources that you read, better books that you read, that will help you.
Yeah. So Bikram, one last thing before we wind up.
Sure. Hmm.
We are also doing some of the mock interviews on this channel. I mean, there are some freshers who want us to take their mock interviews before they go for the real interviews, and I kind of have taken couple of interviews for them. You
Hmm.
know, so sometime if you are free, maybe I'll also want you to be a part of that interview so that they can learn from your way of taking the interview, and they'll have more set of questions with them.
Sure, more than happy.
Okay.
Sure.
Again, thank you so much for being here, Bikram, in this time. I mean, many people are saying thank you to you as well. So,
Sure.
guys,
Thank you everyone for bearing with me for all this while, and I hope that I could help you. Yeah, I mean, we will keep connecting, and if would have more questions, then directly, indirectly, I'll definitely try and help you with your questions. Thank you so much.
I'll drop Bikram's LinkedIn also in the description, guys. If you want to get connected, you can get.
Cool.
Okay. Thank you so much, everyone. Thanks, Bikram. Good
Thank you.
night.
Thank you. Thank you all. Bye bye.
Yeah.